Okay, in this recording, we will be talking about vectors, just an introduction. So let's call our library BS Labs, and we need to look at the murders data frame, right? So let's look at view murders. So you have it here already. So, and last video, we talked about some of the important functions like class. This tells you that murders is data frame. We can look at the first few observations. We can look at the structure of the murders, because it's wrong, murders, okay. And we said also we can look at a specific object. We can look at a specific column, which is, let's say, population. So let's look at murders, population, $sign population. So we can investigate this column, right? Note that this is not just one number as before. So let me close this. It's not just one number, it's a list. It's so many numbers, right? Because we have so many numbers, it's not a single number. We call these types of objects vectors. So this is a vector. Murders, $sign population is a vector. Look, think about it as a column of data entries, of many entries, right? It's not a single number. If you have a variable defined as a single number, it's a vector with one entry, or of length 1. But in this case, we have a vector. This vector has a length of 51 because we have 51 entries. So we have several entries. So how to know the length of your vector? You can use the word length, by the way. Length, murders, the length of murders at population. So the length of word $sign populations is 51. By the way, what if you would like to define this vector, to define it specifically and explicitly to be shown on your workspace, or if you'd like to define it, like give it a name, like population. So assign POP is going to be murders, $sign population. So once you assign the name, you can see it on the data frame, on the workspace here. It's pop. It's defined and stored in the workspace. It's a vector from 1 to 51. We have 51 observations in this vector. And also you can see the length of this, length of pop. So you can use both. You can see the length of pop or length of murders $sign population. But because you have assigned this column a name, so it already has it becomes an object called POP, population, okay? And you can look at the class of this, of pop. The class is a numeric. In a numeric vector, this is important, every entry must be a number, okay? Now the population sizes are numbers, so that's why they are numeric. For example, what if you would like to look at different class? Let's look at class of murders of state. It's character. So vectors, this is a vector, murders $sign state. You can call it ST, let's say state, or let's call it STS, murders at state. So look at this. It's STS. It's our new object. This object contains a vector. This vector contains 51 observation, right? And these observations are all of them character. So to store character strings, vectors can be a character. And as we said, all entries in the character vector need to be a character. So all of the entries have to be character for this guy to be character. STS is a character. So we stored murder $sign state as a new object called STS, but still the state is part of the murder data frame. This is important. Another important type of vectors, we call it logical vectors. So now we talked about numeric vectors, we talked about character vectors, and now we'll be talking about logical vectors. So the logical vectors, they can be either true or false. By the way, if you click on this, nothing's going to happen because it's just a vector. If you just call it, if you try to load it STS here, you can see it. You can see all of these values. If you would like to call pop, load pop, so we have all of the values that assign to this vector. So its pop is a vector, contains 51 observation. So as I said, last thing to do here is define illogical vectors. Logical vectors, they takes values true or false. They must be either true or false. So let's define a value, z to be 3, equal 2. So here the equal is a relational operator. It's asking if 3 is equal to 2. So in R, if you use just one equal, you actually assign a variable. But if you use two equal signs, you test for the equality. So in this case, we are testing for the equality. Z equals 3. Is it equal to 2? So what do we expect to get? We are going to expect to get false. So Z, type Z, false. This is false statement. What is the class of this? Z. What is the class of this object? What do we expect to get? Logical. So we have three different classes. We talked about the class of numeric vectors, character vectors, and logical vectors. Later we're going to talk about factors, a very important topic in R.